Pediatric medication dosing is not just a smaller version of adult dosing. Instead, it's carefully calculated, often based on weight or body surface area. Weight-based dosing is most commonly used, while body surface area is typically employed for critical care medications and chemotherapy. But what makes pediatric dosing unique? Let's break it down. Pediatric medication dosage differs from adult doses. First, pediatric medication dosing uses established safe and effective ranges. These ranges account for metabolism, body composition, and developmental differences. Every medication has a range. The minimum effective dose. This is the smallest dose likely to achieve the desired therapeutic effect. The maximum safe dose, which is the upper limit before the risk of toxicity or side effects increases. Let's look at an example. Here is a pediatric dosing for amoxicillin. Amoxicillin, 20 to 40 milligrams per kilogram per day, divided into doses every 8 hours. The pediatric dose must fall within the recommended low and high ranges. The low range would be 20 milligrams per kilogram per day, divided into doses every 8 hours. The high range would be 40 milligrams per kilogram per day, divided into doses every 8 hours. The dose must be within the range of the low and high doses. If the dose is lower than the low dose, the drug may be ineffective. If the dose is higher than the high dose, then the drug may be toxic. If the patient's weight is 17 kilograms, the low dose is calculated by multiplying 20 milligrams by 17, which equals 340 milligrams. This gives you the daily low dose. If the patient is receiving the medication 3 times a day, the low dose would be 340 milligrams divided by 3, or 113 milligrams every 8 hours. The high dose is calculated by multiplying 40 milligrams by 17, which equals 680 milligrams for the daily high dose. Divide the 680 milligrams by 3, and you get the high dose as 227 milligrams every 8 hours. The prescribed dosage must be between 113 milligrams and 227 milligrams every 8 hours to fall within the safe and effective range. Pediatric dosing requires 3 steps. First, calculate the dose based on weight. Second, check if it falls within the safe range. Third, confirm if the total daily dose is also safe. Let's look at another example. The order reads amoxicillin 250 milligrams every 8 hours. The child's weight is 18 kilograms. The reference safe dose range is 20 to 40 milligrams per kilograms per day, divided into 3 doses. You don't have to calculate the dose to administer based on weight. That is already done for you. But you must determine if the dosage of 250 milligrams every 8 hours falls within the safe dosage range. Calculate if the patient's dose is safe. The low dose range is 20 milligrams times 18 kilograms divided by 3. The low dose is 120 milligrams every 8 hours. The patient's dose is 250 milligrams, which is above the low dose, so that is good. Now you need to ensure it is at or below the high dose. The high dose is 40 milligrams times 18 divided by 3. The high dose is 240 milligrams every 8 hours. This number is lower than the 250 milligrams ordered. This dose is not safe based on standard guidelines. The provider should be contacted to review and possibly adjust the dose. The safe daily range of this medication for this patient is between 360 and 720 milligrams per day, or between 120 and 240 milligrams every 8 hours. Let's look at another example. The order reads ibuprofen 100 milligrams every 6 hours PRN. The child's weight is 15 kilograms. The reference safe dose range is 5 to 10 milligrams per kilogram per day every 6 to 8 hours. Do not exceed 40 milligrams per kilogram per day. You don't have to calculate the dose to administer based on weight. That's already done for you. You must determine if the dosage of 100 milligrams every 6 hours falls within the safe dose range. The low dose range is 5 milligrams times 15 kilograms. The low dose is 75 milligrams every 6 hours. The patient's dose is 100 milligrams, which is above the low dose, so that is good. Now you need to ensure it is at or below the high dose. The high dose is 10 milligrams times 15. The high dose is 150 milligrams every 6 hours. This number is higher than the 100 milligrams ordered. This dose is safe, falling between the low and high dose range. The daily dose should not exceed 40 milligrams per kilogram per day. That works out to be 40 milligrams times 15 kilograms or 600 milligrams per day. If the patient receives 100 milligrams 4 times a day, that would be 400 milligrams, which is below the 600 milligram limit. Again, the dose is safe to administer. The safe daily range of this medication for this patient is between 75 and 150 milligrams every 6 hours, with no more than 600 milligrams per day. Let's consider another example where you need to calculate the dose to be administered based on the patient's weight. The order reads amoxicillin 40 milligrams per kilogram per day, divided every 12 hours, so you would administer in 2 doses. The child's weight is 18 kilograms. The reference safe dose range is 20 to 90 milligrams per kilogram per day in divided doses. The supply is amoxicillin 250 milligrams for every 5 milliliter suspension. This is a weight-based dosage. Calculates the patient dose based on the patient's weight of 18 kilograms. 40 milligrams times 18 kilograms equals 720 milligrams, divided by 2 doses equals 360 milligrams per dose. Set up the problem with the calculated dose. Write out the prescribed dose as a fraction, 360 milligrams over 1. Then write the available medication in a fraction with the units set up so they cancel out, 5 milliliters over 250 milligrams. You calculate the answer by multiplying across. 360 times 5 divided by 250 equals 7.2. The milligrams canceled out, leaving you with milliliters. You would administer 7.2 milliliters of the amoxicillin oral suspension. Now you must determine if this dose is within the safe range, considering both the low and high limits. The low dose range is 20 milligrams times 18 kilograms divided by 2. Twice a day would be every 12 hours. The low dose is 180 milligrams every 12 hours. The patient's dose is 360 milligrams, which is above the low dose, so that is good. Now you need to ensure it is at or below the high dose. The high dose is 90 milligrams times 18 divided by 2. The high dose is 810 milligrams every 12 hours. This number is higher than the 360 milligrams ordered. This dose is safe, falling between the low and high dose range. The safe daily range of this medication for this patient is between 180 and 810 milligrams every 12 hours. The 360 milligram dose is within the safe range. Let's complete another example. The order is ibuprofen 10 milligrams per kilograms every 6 hours PRN. The child's weight is 22 kilograms. The reference safe dose range is 5 to 10 micrograms per kilograms every 6 hours. Supplied is ibuprofen 100 milligrams in every 5 milliliters of suspension. First, calculate the patient's dose. 10 milligrams times 22 kilograms equals 220 milligrams per dose. Set up the problem with the calculated dose. Write out the prescribed dose as a fraction, 220 milligrams over 1. Then, write the available medication in a fraction with the units set up so they cancel out, 5 milliliters over 100 milligrams. You calculate the answer by multiplying across. 220 times 5 divided by 100 equals 11. The milligrams canceled out, leaving you with milliliters. You would administer 11 milliliters of the ibuprofen oral suspension. Now you must determine if this is a safe dose within the low and high ranges. The low dose range is 5 milligrams times 22 kilograms. The low dose is 110 milligrams every 6 hours. The patient's dose is 220 milligrams, which is above the low dose, so that is good. Now you need to ensure that it is at or below the high dose. The high dose is 10 milligrams times 22. The high dose is 220 milligrams every 6 hours. This number is the same as 220 milligrams ordered. This dose is safe, falling between the low and high dose range. The safe daily range of this medication for this patient is between 110 and 220 milligrams every 6 hours. The 220 milligram dose is within the safe range. Just made it. Let's complete one final example. The order is azithromycin, 12 milligrams per kilogram per day, once daily. The child's weight is 15 kilograms. The reference safe dose range is 10 to 12 milligrams per kilogram per day. It is supplied as azithromycin, 200 milligrams in a 5 milliliter suspension. First, calculate the patient dose. 12 milligrams times 15 kilograms equals 180 milligrams per dose. Set up the problem with a calculated dose. Write out the prescribed dose as a fraction, 180 milligrams over 1. Then write the available medication in a fraction, with the units set up so that they cancel out, 5 milliliters over 200 milligrams. You calculate the answer by multiplying across. 180 times 5 divided by 200 equals 4.5. The milligrams canceled out, leaving you with milliliters. You would administer 4.5 milliliters of the azithromycin oral suspension. Now you must determine if this dose falls within the safe range, considering both the low and high limits. The low dose range is 10 milligrams times 15 kilograms. The recommended low dose is 150 milligrams daily. The patient's dose is 180 milligrams, which is above the low dose, so that is good. Now you need to ensure it is at or below the high dose. The high dose is 12 milligrams times 15 kilograms. The high dose is 180 milligrams daily. This number corresponds to the 180 milligrams ordered. This dose is safe, falling between the low and high dose range. The safe daily dose range for this medication in this patient is between 150 and 180 milligrams daily. The 180 milligrams dose is within the safe range. Just made it. When dosing by weight, always confirm max dose limits to avoid overdosing. Check if the dose is per dose or per day. This changes your math. And use the most accurate weight in kilograms. Avoid estimating. Pediatric dosing is precise. It is not just about numbers, it's about safety, effectiveness, and the best possible outcome for every child. Understand the weight, check the range, and calculate carefully. Thanks for watching. If this video was helpful, give it a like, share it with your classmates or coworkers, and subscribe for more nursing education content. You can find more videos at nursevideohub.com. Watch, learn, and care.